Good afternoon and welcome. The presentation, Oil and Gas and Geothermal Co-Production, will depart from a vision of what is our energy mix and its prognosis looking for 2050 and beyond. It will be expanded with the technological advances captured during the classic industrial oil and gas, and will complement with our vision and how we would like to energize my country, Peru, with geothermal energy. The Earth, the upper 10 kilometers, are the most powerful battery available anytime, anywhere. If you add nuclear, coal, oil, gas, wind, hydropower, and solar, if you even duplicate and elevate to the power of 10, this is still a big microscopic amount compared with what is available in our Earth battery, which can last for more than 15 million years until the end of 5 million years ahead. And it's not only electrical production, but it is also heat. What happened with the oil reserves? Venezuela today counts with more than 300 billion barrels, followed by Saudi of nearly 270, and a couple of dozens of privileged countries. They amount 1.5 trillion barrels. In the other side, we have our planet Earth with brilliant points indicating everywhere potential anomalies which can go from very low enthalpy, medium to high enthalpy, appropriate to generate power. Are the traditional oil companies today rebranded as energy companies leave underground these valuable resources of more than 1.5 trillion? No, it will not be possible. Therefore, we predict not a revolutionary process, but rather an evolutionary process. In most of our predictions, however, we see that by 2050, the oil consumption will decrease. The gas will increase. Why? Because gas is less pollutant, and also it could be used as a raw material to produce, for example, fertilizers. And why? Because in the 2050, 2060, the population of the world will maybe reach 10 billion people. And only to feed with the elementary daily bread, we may require up to 300 million new hectares to be grown. That will require fertilizers, that will require energy, that will require water. The coal, however, it will be bumpy as usual, especially in China. But what happened just 2 weeks ago in Spain, where all the renewable sources, wind and solar, were knocked out because of a severe winter, and the electricity reached more than 100 euro per kilowatt hour? The government immediately reopened a coal-fueled thermic plant in Asturias and opened to production. The other sources like hydro and nuclear will maintain more or less the same trend. What will increase is the renewable, and we could see already signals from the EU, their zero policy, and also in Germany, where they predict that more than 60% of their energy and storage will be from renewables. In my country, we have a very interesting scenario which is similar to more than 150 other countries which doesn't belong of these couple of dozens of oil producers, where we have hydraulic 39%. We have renewable 5%, where eolic is nearly 3 and solar is 2. But more than 56% of the energy, the electricity, is being generated by burning millions of gallons of residual oil. Where is the geothermal energy? Doesn't appear in the statistics. And why it doesn't appear in the statistics? Because, like other 150 countries in the world, it's not included in their national energy policy. Due to this geopolitical crisis, 32 years ago, we started looking at this geothermal energy, and we built and typewritten in a Singer machine a series of workflows departing from how and which will be our exploration strategy for volcanics or rocks more basin type. We saw already the geothermal development models and even the connection to the net and strategy. These workflows today are very valuable because the master students and PhD students, they are populating these workflows because it's a wish list, that very, very detailed wish list, and they use it for data analytics, machine learning, and some even go far away trying to do even artificial intelligence. What has happened, and it is the situation of more than 150 countries in the world, is the conceptual model in the left, which is from Peru, and you see there are 3 volcanoes already. You see the seal in brown, you see the reservoir in light blue, you see the faults, the ones which are controlling the hydrogeochemical system to explain the presence of, for example, thermal waters up to 240 degrees at surface. What is missing here is what we see in the other side. We have defined more semi-quantitatively where is the hot pot, where is the kitchen, where is the hot kitchen, and we see some delineation wells, and we see the hydro geochemical system, we see isotherms. This is the gap between the conceptual model to adding more value by geophysical measurements. This project is being built for 10 megawatts plant in October last year. Now in the area where I come from, you see a trend of faults north, west, southeast. They are very deep-seated faults because these ranges are showing the highest mountains in Peru, approximately 7,850 meters above sea level. And at 5,400, you can still enjoy hot waters of 60, 70 degrees. On the other side, you see this very nice conceptual model of anticlines, inclines, faulted, indicating the occurrence of thermal waters at surface. In other parts of Peru, we have a much more complicated and challenging scenario. We have volcanic seals and different type of structural development, but all of them prone of high enthalpy waters ready to generate geothermal electricity and or hot. What is missing is the geophysical measurements. You work days and days in a river, look at these pebbles, monotones, but just a little attribute is showing how brilliant they are, and you can identify that these monotone pebbles are not that. That's what we need. We need to promote more and more geophysical methods to add another dimension to our conceptual models. In 2018, Karsten was appointed manager of the geothermal group in this oil company and arranged a meeting in the southern part of the country where invited all the experts to decide which are the benefits from the technological area in petroleum which could be transferred into the geothermal. It was assessed that exploration reservoir management is nearly the same. The great benefit is going to be by drilling well completions and logging. Why drilling? Because they are drilling this favorite field of mine me, the troll from deep waters of 180 from fixed platforms, concrete platforms going to the seafloor, and from there they navigate the wells and position like here over the Bergen City multilaterals, which are at 2,800 meters below, and the OD of these wells are 658. And here over New York, it means that we are draining practically 30% of Manhattan with this multilateral. And the other side, we see how days ago New York is surreal, no traffic, completely frozen. Here we are also reading that they have plans for geothermal energy for intelligent buildings. Over Rio de Janeiro, 15 kilometers of sun face contact in one of the nicest sands in the world. It is like beach sand. It has 33 Darcy's in permeability, fully saturated of light, smelling of energy oil. Over Oslo, practically we are draining 4 by 4 kilometers with these 5 branches, which have lengths of 2 kilometers to 3 kilometers to 4 kilometers. Why is this important? It is because if we didn't think innovation limited by the number of entries, this could require 15 to 20 low deviated wells. It is very important that the jewelry we put in the well reach TD. It's a very complicated jewelry, and in this case it is placed 3 meters above the oil-water contact for reasons of field management. And if this jewelry, the steel jewelry, doesn't reach TD, all the other aspects are not relevant. It's very important drilling completions. And in geothermal, I'm going to tell you in Spanish, el pozo y la completación se convierten en el reservorio. The well and the completion is converted into the reservoir, especially in these ESG type of projects like the Forge, etc. in the US. How this started, you see here a seismic section where clearly depicts the faults, antithetic faults, the deepened beds, and suddenly in the middle of the section you see a horizontal line which doesn't follow the deepening of this layer. This is a technique called bright spot, flat spot, separating in the upper part gas, the saturated layer of 8, 12, 15 meters, and below water. This technique was already discovered in Canada, and it was kept in secret until, due to the tremendous impulse of seismics, the academia also rediscovered. They even went farther. There is also the dim spot opposed to the bright spot. There are also some pitfalls. For example, a basalt layer can behave the same way. Tremendous revolution because the number of discoveries was enhanced. Before you need to drill 18 to get one discovery. This was dramatically improved. The same company put into practice what it was recommended in the meeting in the southern part of the country, and it looked for a location in Iceland, where you see in the middle aerial map, that's the reservoir, geothermal reservoir in blue, depicting temperatures of more than 600 degrees, supercritical, the yellow less than that. Here they use satellite imagery, airborne data, refraction seismics, everything to characterize this reservoir. A series of wells were drilled, 6 wells up to 2.5 kilometers. One particular one was extended, the deviated well up to 4.6 kilometers, And there the brines injected reached supercritical temperatures of 600 degrees. The benefit is that each of these wells in such a limited area can produce 100 megawatts per well. 100 megawatts multiplied by 1,500 houses, it's enormous. What was learned is also more than 100 new recommendations, both for fluid circulation, material technology, measurements, etc. The other advantage was introduction of monitoring. As you will see here in the left-hand side, you have a long horizontal well. The total length reaches nearly 19,000 feet, and you see how the green curve is moving. It is the results of the fiber acting as a monitor and being interrogated by a series of lasers, millions and millions of data points in the order of terabytes. And you see how it is moving, showing which parts are active, which are not. Very important, because we need to know how the well behaves. We want the well to produce along the entire horizontal section, and if not, the next well to be stimulated accordingly. On the other side, we have a distributed acoustic sensing image, real time, so in bright sections of related to the fluid injection, of temperature of the gauges, pressure of the gauges. This is the way to monitor geothermal. Also, the geothermal fields are very similar to unconventionals, where we choose a target. All of these properties are added into a polygon of influence, and then are guided away into the grid, and where a series of attributes are added. For example, here it's lithology, here it is effective porosity, here it is the total organic content or breathability. If we have microseismics monitor, and we also add for all of these stages. But here, the operational question is, where is the sweet spot? Because we want to place the next well. In unconventionals, what you stimulate is what you produce. Very similar to the geothermal, where the operational question is, where is the hot spot? Where is the kitchen? Where is the hot kitchen to place the next well? Now in co-production, we have Germany, the nice Rhine graben, an attribute of an aerial photograph just putting altitude, fantastic. The other side, we see the model, we see the integration of seismics, logging, we make the model, because now we have this injector well in blue, low deviated, 25 degrees, the producer higher deviation because we want much more contact. The other side, we have the model, which is not anymore conceptual. We have measurements which are indicating these anomalies up to 25 kilometers down. This is how it looks like the plant. The only thing visible is the maintenance pool. We have in red the injector well, in green the producer well. Gentleman chief is showing the unit where the electricity is being generated. Everything in a closed circle. Of course, we need to maintain the well, but I asked chief what is the longevity of this project. He told me we have time, 350 years. This took time from 2003 to 2008, nearly 5 years. The result, savings of 6,000 tons of CO2. We have heat generated 9.2 million kilowatts hour per year, providing electricity to the hours of 7,600 hours per year, 22 million kilowatts per temperature 160 degrees. When it is curved, the equipment didn't resist. In the middle, the aerial map where we see dark green, the 160 degrees anomaly, in other colors less than that, ready to be monitored like if it was a reservoir. The yield, very important, it was 50 to 80 liters per second. If this was an oil well, it would have represented 50,000 barrels per day. Only in Brazil, I have seen 35,000 barrels per day in the pre-salt. The cost, 20 million. And a completely closed system, nothing is wasted, no pollution. And the other value is that in other areas in Germany, they are going to also extract boron and lithium, considered as strategic elements for the community. And now we have the Peru, the southern part, we have the logistics, we have the infrastructure, the red is there, up 7 volcanoes surrounding this area, the altitude 4,300. We want to do a 50 megawatts plant, have the conceptual model. We need more seismics, more geophysics, more methods to map. The other co-production areas, like this example in Canada, they drill for oil and found an aquifer so rich in lithium that it is computed to have approximately 7 million tons of equivalent lithium carbonate, 18,000 per ton, and $18,000 per ton. It just increased it 14,000 because in the log for work orders there are millions and millions of cars. In Peru, we have all of these dots to the left-hand side indicating 537 outcrops of geothermal waters, even in the jungle. In the southern part, associated volcanoes, in the northern part, two regional faults, and the system of railway, 6,500 kilometers, which we want to build to, along these routes, develop sustainable areas. It could be by gas. We have 18 basins. In the jungle, they have been operating for a while, but they are depleted, and it's predicted by 2030 shortage. In the coast, we have 10 basins, but they are in the stage of the seismics, and it will take time to be declared commercial. It could be solar in the south, it could be oil in the north. What we need is energy to energize and put my country on track. The red dots showing that these trains, high speed trains are circulating twice the world. Our social outreach is related to these kids. The last year we have had 761 kids participating in this artistic competition, Volcanoes and Society. Here you see some of their artwork. They are understanding, even the parents now they talk about volcanics. The volcanics are hazards, but also has been the sources of mineralization, of prolific mineralizations along the Andes, which today are exploited commercially. They have also done their, with limited resources, they are done their 3D modeling. We are very proud, my countrymen, kids, the future of Peru, which are going to be operational in 2050, 2060. They are already understanding that without energy, there is no health, there is no human rights. And what I would like to do here is a recommendation. Don't transfer linearly aspects of costs and or exotic experiments done in the oil when it was over 100 barrels. Be innovative and creative. Thanks to many of my team, the GEO team, which is from 4 universities, Universidad Nacional de Ingeniería, San Marcos, Puno, Titicaca Lake, and Tacna, which are following our continuing education pipeline for future talent. And Mikel and Michelle say thank you to you, showing their geothermal well in our garden. Thank you very much, and look forward to some questions.